Welcome back to another episode of TheFatRat. And in this episode, I'm going to show you how to install the Longhorn system to your cluster. Because we all need to store our data somewhere, but we want it to be fast, reliable, easy recoverable without maintenance. Now, I'm going to show you all of that, and I'm going to try to cover all the bits of the Longhorn system, but I'm going to condense it, so I'm only giving you the basics to set it up yourself and just start using it. Now, here's a list of timestamps for those who cannot wait and want to jump ahead. Now, let's dive in. I'm Garrett, and this is TheFatRat. So what is Longhorn? Longhorn is a cloud-native distributed block storage system. It's a whole bunch of fancy words for saying that you're storing your data on multiple nodes as blocks, meaning everything that gets written is a little tiny block, and when it gets written to your hard drive, it also gets written to a second one. And in this case, it is distributed, meaning it is also written to another node, so that if one node fails, the data is available on another node or multiple, and then your deployment from your cluster, your pod, can move over automatically and pick up where it has left off on that other node where the data is also stored. Now, sounds really complicated, sounds really fancy, so the best way of making you understand what Longhorn is I'm actually gonna show you. So let's do that right now. So I'm gonna walk you through the several components of Longhorn, explain a little bit about everything, and that will give you a better grasp of what Longhorn is, because seeing makes it a lot easier how cool it is. Let's jump to the Longhorn dashboard so you can follow me along. Now, here we are in the Longhorn dashboard. So what you can see right now is everything looks good. Everything is green, right? Now, here you can see also I have this behind me. So I'm going to pop out for a few seconds so you can see what is behind me. So here I have my 4 nodes of my cluster. Now, and what you can see also here is I have 11 volumes. They're all healthy. And I have 2.24 terabytes available. I have 600 gigabytes reserved. I used 700 and nothing is disabled. And here you can see all the events of the Longhorn system. And apparently you can see it successfully made some snapshots of my data. Now we're going to go to nodes. So I have 4 nodes in this cluster. Everyone is part of the Longhorn system. You can see all kinds of replicas. I will get to that in a moment, because that's the cool part. And you can see how much is allocated, how much is used, and the total size. Now you can see I reserved 150 gigabyte on each of my NVMe drives to be used by Longhorn. Let's go to edit nodes and disk, and here you can see everything is up and running, everything is green, storage available, total, and you can see I reserved 150 gigabytes, which is available for scheduling, which means that your cluster can use it to create volumes in that space. Now we go to volumes, and that is the actual magic. So here you can see all my volumes, and here you can see, for example, the first one I have created as a 25 gigabyte volume, currently is using 71. Don't be afraid why it is over that initial 25, because the 25 was the initial I created, but then we also have a lot of backups, snapshots, etc. So this is actually the volume of my GitLab. Now let's look into one of these volumes. And here, with this overview, you can actually understand how amazing Longhorn is. Because what do we have? We have a single volume, but as you can see, there are two replicas, one on node 6 and one on node 8. Now, I can actually check quickly, and I cannot see that here, but I can quickly check my cluster. It is currently attached. It is running because my GitLab system is running. I can check in the background for you guys. Let's go to pods, GitLab, and what does it say? It is running on node 6. Now, so as you can see here, this right one here, node 6, this is the actual data where my GitLab is writing its data. But everything is written, gets also written to a clone on node 8, which means that if I would reboot node 6, it will move either to node 8 or it will move the data of node 8 to the new node where GitLab is being started. So let's say I'm rebooting node 6, or I'm telling the deployment of GitLab, hey, you need to move over to somewhere else. Let's say node 5. Then it will take and create a new volume on node 5, move the data over, copy it all over, make sure everything is in sync, kill off the one in node 6, move the instance over, voila, it will work and continue to work without any data loss. This is what is so amazing about Longhorn. And because I'm using the NVMe storage of each node, this is super fast. The second amazing thing why I like Longhorn is here you can see snapshots and backups. So you can see that it's taking a daily snapshot. Also, it takes regular full backups. And it keeps everything in sync. And instead of jobs, I'm using groups. And you can actually see, well, I'm not using the group GitLab. I did assign it so that in the future, if I want to create specialized jobs for my GitLab instance, I can give them the group GitLab. We can talk another video about that little trick. But for now, you can ignore this little marker that the group doesn't exist. But as you can see, this volume actually is using the daily group, the monthly, and the weekly group. And let's see, we have a whole backup list of all my backups and snapshots that are being taken automatically, the size, etc. These are apparently full backups. And you can actually see all the data that it is taken. And of course, events for this volume currently empty. So this gives you an understanding. And the thing is, you can actually define how many replicas you want of your data in your cluster. For example, I run my own password manager, Vault Warden. And if I would show you guys just for a little show, you can see, because this is to me high critical data, I'm running in a critical, which in a mode I defined myself as critical, which runs 3 replicas, which means that I can restart one node in my cluster without any problem. It will start moving over data, copy over data, and everything is good. Then we got our recurring jobs. Here is where I defined all my recurring jobs, like daily snapshots, daily backups, snapshots every 6 hours, snapshots every 8 hours, cleanup of my snapshots so that it will not fill up my disks. But then the question is, where do we keep all that data? Well, that's the beauty of it. I'm sending all of my backup data of Longhorn to my Synology. And I'm using NFS for that. So when we go to backup, you can see all my backups and when they were taken, etc. And the best part is we go to a backup target, and this is where they're written. And the default backup target for my Longhorn system is, as you can see, NFS and the data core.local That's my Synology. And you can actually see the path. It's written to volume 1. That's my RAID 6 volume. And it's written to the K3s folder. I actually exposed that in my previous video, how to set up NFS provisioner. And it will set up my backup target to backup Longhorn. And it will write all the backup snapshots organized to that location. No management at all. Best part is you can also restore latest backup, create disaster recovery volume. Now, this is why Longhorn is so amazing. You can define volumes for your deployments, but also make sure there is a replica of that data so that if that deployment fails, goes down, has to be moved, it can continue over to another node, continue there. And I am using the configuration option in Longhorn to ensure that the data is as local as possible, locality. That means that Longhorn will try its best to make sure that the data is as close to the pod as possible, preferably linked on the pod itself, meaning that if the pod is running on node 5, then Longhorn will try its best to keep the data, the volume that it's writing to, also on pod 5. So here you see how amazing this is. No maintenance at all, and I can quickly and easily restore for my backup. So let's deploy Longhorn to our cluster. Let's deploy Longhorn. Now, I've made it very easy for you guys how to deploy your own Longhorn system. You only need to make a few tweaks depending on your own personal situation, and then you can get Longhorn up and running pretty fast. So let's dive in. We're gonna jump to Visual Studio Code. I'm using the same repository I've been using in previous videos. Link down below where you can just copy the code or directly start using it. Now, let's get started. So here's our repository with our Longhorn deployment. Now, what I've did for Longhorn this time is I'm using a customization, which means that you take a default setup and you can run your own customizations over it. I will make another video how that works in depth, but this way you can simply use the kubectl with the customize subcommand, give the directory Longhorn, then pipe that through kubectl apply, and your Longhorn should be up and running. Of course, you do need to make a few tiny changes regarding your own personal situation, how to set it up. So let's run through that. I provided a README for you guys, how to deploy it, but also how to uninstall it. The reason for that, because storage is so critical, Longhorn actually comes with a protection against deletion and removal from your cluster. Those commands are also listed, so if anything goes wrong during your deployment, you can simply run these commands and then kubectl command, but instead apply, you can use the delete. So you use kubectl customize Longhorn, and then you pipe that through kubectl delete -f dash. That's it for the documentation. So let's run through the customization setup. And that's basically this where it all starts, your deployment. So we're deploying this to the Longhorn system namespace, and we're using the default Longhorn Helm chart. And for this Helm chart, the values will be in the resources directory helm.values.yaml. Also, I am providing additional resources, which we're going to go into in a few moments. Some patches. Reason is I am patching the default Longhorn storage class with a few preferred defaults of my own, which I think you would find quite beneficial also to yourself. So let's run through our configuration of Longhorn first, and then through all the other setup that is included in this deployment. So what we're going to do is first we're going to run to the Helm values. Now, It's important that you set up a few default values. There are two things that you actually must do here. You need to ensure that every node has a directory where Longhorn can write this data. And I actually create a directory data/data/Longhorn that's also created during my personal Ansible cluster deployment. The link of that repository will also be linked down below. So if you use that, then it should all be in place. If not, make sure that each node will have that directory pre-created, because that is where Longhorn wants to write its data. The second thing is I am setting up a default replica of 2. Before we dive any further, I have also provided additional storage classes with more replicas, some additional settings, which we'll dive in a few moments. No down pod deletion, just do nothing. Allow recurring job while volume detached. That means that we still can make snapshots or backups of volumes if they're not attached to a pod. I always want to make sure my data is safe. That is why I am allowing this. The name of the default Longhorn storage class, that will simply be Longhorn. I'm disabling metrics, and storage minimum available percentage is 10%. Now, finally, what you absolutely need to do is you need to set up your backup target. So I'm using NFS. So if you have the NFS common package installed, NFS provisioner, etc., so you can simply use your own NFS server. You can even use Windows Samba. But if you want to use anything else, maybe a local disk, etc., please make sure that you then read the Longhorn documentation to use a backup target that is suitable for you. Also, I am disabling the default ingress because I'm using traffic from my previous videos where I actually set up a dual traffic configuration with an internal and external load balancer to separate my internal and external traffic. It's also the way I set up all my access to my tools. That's why it was easy for me to show you guys, hey, Longhorn.K3s is my Longhorn dashboard. It all runs over my internal load balancer. And that is why I am disabling it here, because I'm providing that. If you want the default, then you can actually enable that. And I do recommend in this case that you go to the default Helm chart values. I will post a link down below where you can read those values, make additional changes to your configuration to get the default ingress up and running with your host name, etc. for your Longhorn dashboard. Also, enable PSP is false. There's also a note here because that's deprecated in older versions Kubernetes K3s since 1.25. So just leave that as is. Now, these are just the basic default settings to get Longhorn up and running. Now, the trick is, if we go back to the customization, you can actually see that we have additional resources, namespace, that will simply set up our namespace Longhorn system, ingress, backup settings, and then some storage class, and then we patch the default storage class. So let's go to ingress. Ingress will be basically the setup I'm using for the setup of the internal external load balancer. I talked about a few more times. I will link that video also down below and up here. So in that way, it's easy for you to get that up and running. Otherwise, you set up the default ingress and you just remove loading this file from the customization. Pretty easy. What else do we have? Then we have backup. Now in the backup, you can change this, but this is one of the best features I'm providing you guys. This will set up all those different backup jobs you saw, the daily, weekly backup, critical backups that will make snapshots every hour, etc. This will load all of that configuration into Longhorn, which is pretty cool. You can just go through it, make changes when it runs, etc. Just read through it. you should be able to figure it out. It's just a standard cron expression when it runs. So yeah, this way you can make changes to the default backup configuration I'm providing, because normally Longhorn doesn't provide any of that and you have to configure it yourself. Then settings, and this is going to take you some time. These are the default settings that I'm overriding in the entire Longhorn system. Now, not everything is working as expected when you're using the default Helm values, so I'm just loading this to ensure that all my values are set up correctly. So it will load the directory, things like locality, best effort I talked about earlier, when it makes sure that we'll try to locate the volume and the replica to the node where the pod is running. And you just have to ensure that things like directory, etc., is all correct in this place here. If you do not understand a value completely, you can also look it up or simply load this and then go through the Longhorn dashboard and go through every setting with the description, changing it to your own preference. Remember, this is an important step in post-deployment. Go explore Longhorn because there are some post-configuration things you have to do. And then finally, 2 storage classes. I'm providing you guys with a critical storage class and a multi-node read-write storage class. And the last one is when you have multiple nodes and you want them to write to the same volume. Longhorn can actually provide that. And here in the folder storage class, you can actually see the storage class I'm providing you. So I create a critical storage class. It's called Longhorn-critical. So when you're making a PVC, you can actually reference this storage class. You can actually say, hey, make a new PVC, give me 10 gigabytes and use storage class Longhorn-critical. And it will use these settings within Longhorn. In this case, it will create 3 replicas instead of default 2 we did earlier. Also, it's providing recurring job group critical, and it will activate there for all the critical backup jobs like snapshot every hour, etc. The other one I am additionally providing is the Longhorn critical read-write, multi-read-write. And this one is also 3 replicas, and it is providing you with a multi-node read-write. So when you have 2 pods and they both need to write to the same location without any issue, you can use this class. Now, finally, we have our patch, and that is storage class default. I'm overriding the default storage class. I'm doing that to activate the default recurring jobs I want to have enabled on the default storage class. That way, that when I create a PVC with the default Longhorn storage class, it will default have those jobs daily, weekly, backup, monthly. The whole thing will be attached to that new volume, and I don't have to worry about backups. So yeah, that is the reason I am doing an override, making sure number replicas 2, still timeout, so that if a node is rebooted, it will have some timeout and before it starts recreating somewhere else. So in a normal reboot, nothing would really go broke. And of course, the best effort and a few other settings. You can simply go through Longhorn documentation, go through everything and make adjustments as you see fit, but I mainly use it to ensure that the reclaim policy is set to retain, not delete, so that when a pod is deleted, the volume will remain in Longhorn. It does not automatically delete data, because I'm the kind of person who would rather do a few manual clicks after a mistake to delete data deliberately than have a pod or deployment be destroyed and then realizing, oops, my data is gone. So that is why I set almost all my reclaim policies to retain. That's a very important thing for you to realize. And that's it. And when you have done all of this, you can simply go in the root of this directory and run kubectl customize Longhorn, pipe that through kubectl apply -f dash, and then your Longhorn system should be deployed. And when you're done, you'll end up with this. This is the Longhorn deployment in my system. It will have a bunch of pods running. It will have multiple managers to manage everything, multiple UIs, instance managers, all kinds of internal stuff for Longhorn to make it work. And this is your entire Longhorn system. And then you should be able to access your Longhorn through your Longhorn dashboard. So finally, let's go to post deployment. So we need to go into post deployment. And I recommend two things. First, run through all the settings. Make sure that everything is how you like it to be. And then configure the disks of Longhorn to use. So let's quickly run through that, and then you're done and you can start using it. So let's jump to the Longhorn dashboard. Here we go. So when your new Longhorn system is up and running, I recommend you go to settings, you go to general, and you're gonna make sure that you read through everything and you simply go through every setting, make sure everything is okay. So once you've done that, I do recommend going to the backup target and making sure that status goes to available. You can go through all the other settings and configuration. You can just look around. It's your system. Don't forget that. And then what you're gonna do is you need to assign disks. So when your new Longhorn system is online, it will be deployed to all of the nodes in your cluster, but the status I have here, you probably don't have that because you need to allocate some part of the disk. So let me show you how you do that. You go here behind me. So I'm gonna quickly show that. Here behind me, there is an option, edit node and disk. So click that, I'm back, here we are. And your node scheduling is probably disabled. So what you need to do is you need to enable that. And what you can actually limit, and you can also tag certain things. And what you're gonna do is at the bottom, add disk, because this part is probably not shown. You can say add disk. You can give a tag to a disk. I have actually given my disk NVMe as a tag. You're gonna give the file path. I'm using file system. You're giving the path where Longhorn can store its data. Then you give storage reserved. And the moment you press scheduling, enable, save it, and then in a few moments, that node will be prepared and come online in Longhorn. You have to do multiple for everything to work correctly, and then you should have a Longhorn system up and running. So with all of this, you will be able to set up your own cloud native distributed storage solution that will allow you to have backups, easy recovery, low maintenance, and great speed in your cluster. Thank you for watching. I hope you enjoyed this video. Like this video, subscribe, and I hope to see you in my next video. I am Garrett, and this is TheFatRat.